Lesson 3.7, Solving Absolute Value Inequalities. So this lesson, ladies and gentlemen, we're going to be working with absolute value, but we're also going to be connecting and combining the compound inequalities that we learned in class from lesson 3.6. So when we're thinking about solving absolute value inequalities, there's certain steps involved, and I'm going to show you those steps. But also think, when solving absolute value inequalities, you first isolate the absolute value expression, and then you're going to solve by setting up compound inequalities. Remember, an absolute value expression is something like this. The absolute value of 6 is going to equal 6. That means how many jumps it takes to get from 0 to 6. Same goes for the absolute value of -6. It's going to equal 6 because it takes you 6 jumps to get from 0 to 6. So just wanted to briefly review absolute value with you. Let's get started on some examples here. So example number 1, we're going to solve each inequality and graph the solution. So steps to think about. The first step is we need to isolate the absolute value. The second step when solving is we're going to set it up. We're going to write inequality as a compound inequality. So let's get started with these examples. The first one, we have the absolute value of x minus 3 is less than -1. We first need to isolate the absolute value, meaning we need to isolate this absolute value of x by taking away this -3. So I'm first going to add 3 to both sides. So what I'm left with is the absolute value of x is less than 2, because -1 plus 3 gives me 2. Now, we've done the first step, isolate the absolute value. We now need to write an inequality, this inequality, as a compound inequality. So the way I'm going to write that is going to be x can be less than 2, or x can be greater than -2. So that's how you would write an inequality based on this absolute value inequality situation. So let's graph this. I have my number line. I will have an open circle at -2 and an open circle at 2, because the compound inequalities are stating x is less than 2 or x is greater than -2. So x is going to be any value based on this compound inequality between -2 and 2. Let's look at the next example. We have 3 plus the absolute value of x plus 2 is greater than 5. We first need to isolate the absolute value by having the absolute value of x plus 2 all by itself on the left. So I will first subtract 3 to each side. So what I have, I've isolated the absolute value to have absolute value of x plus 2, which is greater than 5 minus 3 is going to give me 2. So I've solved for that, but what I need to do now is I need to write a compound inequality given this situation. So I can have my first compound inequality to be absolute value of x plus 2 is greater than 2, or the absolute value of x plus 2, which is less than negative 2. Okay? So now let's solve. I'm going to subtract 2 from the left, 2 to the right. So what I'm left with is x is greater than 0, or let's solve for the other part here. We will subtract 2 from the left, 2 from the right, and I'll have x is less than negative 4. So isolated the absolute value. We set it up as two compound inequality situations by just reversing the inequality sign and making the second become a negative 2. So here's my compound inequality. X is greater than 0, or x is less than negative 4. So now let's graph. I have my number line. So we have x is greater than 0. That is going to be an open circle at 0. X is greater than, so I'll shade everything to the right since x is greater than 0. Or x is less than negative 4. I have an open circle at negative 4. X can be anything less than negative 4. So that is my graph. I've solved for each and I have graphed. Now these next two examples, they're a little different than the previous two. What you'll see when you're doing problems out of the book is it might say solve each inequality. And these are what we call special cases of absolute value. So let me explain this. So when we look at the first example, we have example number 3. X, the absolute value of x plus 4 minus 5 is greater than negative 8. We are still going to think of this as isolating the absolute value. So for this one here, I want to add 5 to the left, 5 to the right. So when I isolate x, absolute value of x plus 4, I'll have absolute value of x plus 4 is greater than negative 8 plus 5 is going to give me negative 3. Now let's look at this. I want to get it so x is all by itself, or not even we need to get x all by itself. We can just leave this the way it is to have the absolute value of x plus 4 is greater than negative 3. Can we plug in any value for x to make this true, to make this inequality true? Think about it. So if I put in any value, let's say negative 10, negative 5 for x, negative 10 plus 4 gives me negative 6, the absolute value of negative 6. Would the absolute value of negative 6 be greater than negative 3? Yes, because the absolute value of negative 6 would be 6, and 6 is greater than negative 3. So in this problem that we've solved, can we plug in any value for x to make the inequality true? And that is yes. So the answer for this one is going to be all real numbers. For x, meaning we can put any value in for x to make this inequality true. Let's look at example number 4. It's very similar, but you'll see just a few different things with this one. Again, for this, we're going to isolate the absolute value, so I'm going to subtract 9 to each side. So what I have here is I have the absolute value of x minus 2 is less than negative 2. Is this a true situation? Can we plug in any value for x to make the inequality true? Oops. And the answer to this is going to be no. Because think about this. If I plug in negative 4 for x, negative 4 minus 2 is going to give me, again, negative 6. Absolute value of negative 6, is that less than negative 2? It's not. Any value plug in for x is not going to make the left side less than negative 2. So this is no, and this is a no solution situation because we can't plug in a value for x to make this a true inequality statement dealing with absolute value. Our last example, we have a story problem. It says a pediatrician recommends that a baby's bath water is 95 degrees Fahrenheit, but it is acceptable for the temperature to vary from this amount as much as 3 degrees Fahrenheit. Notice they want us to write, solve, and graph an absolute value inequality to find the range of acceptable temperatures. So it can range anywhere from 3 degrees, needs to be at least 95, but it can range 3 degrees above or below that 95. So I'm going to set up a situation that shows the story problem. So I can call T my temperature, and the way I'll set up this problem is the absolute value of T minus 95 is going to be less than or equal to 3. Watch how I solve this. I'm going to set it up like this, and then I need to set up the compound inequality, or T my temperature minus 95 is going to be greater than or equal to negative 3. So now I'm going to solve these compound inequalities. So what I have here for this first one, T is going to be less than or equal to 98. Okay, or adding 95, adding 95, T is going to be greater than or equal to 92. So what I can have here, the way I would write that would be T is, we'll have 92 is less than or equal to T, which is less than or equal to 98. So the temperature of that bath water can range anywhere from 92 to 98. Let's graph this. So I have a closed circle at 92, closed circle at 98, and T is going to be any temperature between 92 and 98.